So yesterday we talked vertical shifts. Today we talk horizontal. So now, when we're down here towards the bottom, again, just a reminder, K is my up and down, my vertical shift of this graph. C, however, is going to be my left or right, my phase shift or my horizontal shift. But it sort of is like the other shifts that we've done. This is kind of our liar's shift. You're like, what a liar's shift? Yeah, because when it's positive, it moves left. Now, that's the opposite of what you would think. You'd think positive would move right. But positive is going to move it left. Negative is going to move it right. Just like, again, when we've done parabolas, logs, square root functions, and all those other things. So that hasn't changed. So then, that also, though, can switch my period starting and ending values around. It depends. The period itself won't change, but where it starts and ends can, depending on what the shift is. So, for instance, we're trying to think about what the period and the phase shifts are going to be on these. So remember, my period is taking my B value, and whenever I'm taking one of these, I take 2 pi, because you'll notice these are all sine and cosine, and divide it by that B value. So what would my new period be for this particular? Ooh, I'm hearing 2 answers. I'm hearing pi and I'm hearing 4 pi. I need a tie-breaking vote. 4 pi. When we divide by fractions, value gets bigger. So dividing by a half, same as multiplying by 2, is 4 pi. My period shift, what's that minus pi going to represent? Which direction are we going? Okay, we're going to be going right pi. So whereas normally, with my period being 4 pi here, I'd be going from 0 to 4 pi, okay, is where this would end up. With the shift, I now would start at pi and then end at 5 pi. So that's what we mean here when it says it's important to think about the period. It's still a 4 pi period, but it just has a different starting and ending point. And that's going to be the same on all of these. So when I get to B then, let's say, what's my new period going to be on letter B? Pi, because again, I take 2 pi and divide it by whatever my B value is. So now it's like half of what it was before. What about my period? Ooh, almost did it wrong. What about my phase shift? Left pi over 2. So now instead of being from 0 to pi for this particular period, I'd be going from negative pi over 2 to positive pi over 2. The length of the period didn't change, just where it started and ended did. And again, it's the same all the way through. We noticed yesterday that B value can even be pi. And if that's the case, so that simplifies life, even more. My period just ends up being 2. Ooh. Okay. Now, what would be my ifs this time? Ooh, I gotta be careful when I say that. Right. I'd be moving right 5 for my phase shift, but I still would have to remember I'm also going to be moving that up 3. If you have that many things going on, here's my suggestion. You're always going to want to get your period set first. Because once you do that, then you can do any phase shifts, then any vertical shifts. It kind of keeps life simpler if you take them in that order, sort of in the order that you see them in your trig function itself. Ooh, get a fun one at the end here. Now you're looking at this and you're going, wait a minute. This looks kind of interesting. What's my period going to be this time? This one's a little tricky, isn't it? So let me rewrite this and let's see if it makes life a little bit easier. Okay, let me change the question a little. What's my b value on this going to be? Pi over 3. So I'm going to have 2 pi divided by pi over 3, which would be 6. Because again, if I took 2 pi and divided by pi over 3, it's the same as multiplying by 3 over pi. The pi's cancel, and I've got 2 times 3 or 6. So don't let, if it's written in a different way where the k value ends up here at the beginning instead of the end, rewrite it if you need to. So what would my shifts be on this one then? Right, we're going to go left 1, and then here again, we'd end up going up 3. But I would even consider writing it this way because you want to think, I want to do my period, my left or right shift, my up shift, and then I can even bring my amplitude into it if I need to. And we'll talk about the order of that when we get finished up here. Whew. So now we're going to start blending this stuff together. I actually start drawing some pictures here. So let's see what we got to work with here. K value this time. Do I have any up or down shift? No. No up or down shift this time. I do have an A value, though. That -2 is going to be my value working there. Then my period didn't really change at all, so it's just 1. So that's going to stay at 2 pi for my period. Now, here's one thing I will mention that we haven't talked about yet, because we haven't done a lot with negative A values. My amplitude is always going to be the absolute value of A. So even if I have a negative A value, it doesn't mean my amplitude itself is going to be negative, because it's more like a distance is going to be. And then what's my phase shift going to be? Where am I shifting or moving? Right, pi over 2. So here's what we've got that we're having to kind of keep an eye on here. If I think about my base graph with this, okay, and I'll just put this up for a minute and I'll get it back down. If I think about my base cosine graph, the amplitude is going to change my y values. The period and my right phase shift are both going to change these values. So I am a very big proponent, especially when there's multiple shifts like this, of getting myself a little bit of a chart working here, just so I can visualize what everything is and how it's all going on. So I'm like, okay, where do I start? Always start with period. So I think about this and I'm like, okay, my period's not changing. So since I notice there's going to be a phase shift, I'm going to make myself a little tiny writing over here with what my base values would be. And again, with sine and cosine, those are always my parent graph or base graph values. And if you can't see my little tiny writing, it's just 0, pi over 2, pi, 3 pi over 2, 2 pi. But I'm shifting all of them. They're all shifting right 90 degrees, right, pi over 2. So I'm going to add pi over 2 to all of these, and those are going to be the actual ones that I'm going to use. My period itself didn't change, all the values just shifted to the right, because from pi to 2 to 5 pi over 2 is still 2 pi, still my same period. So then I change up my value look and I go, okay, normally when I'm doing cosine, my y values are at 1, 0, -1, 0, and 1. Because at this point, we should be getting these down to where they're just kind of entrenched into our brains. So the only thing I've got working this time is I'm going to multiply all of those by 2, my y values. So with cosine, my y value would normally be at 1, but I'm going to multiply it. But again, remember, my a value is -2. So they're all going to be multiplied by -2. So the values that you see in purple, or maybe look like blue to you, like it does to me, and green, that's what I'm actually going to graph for this one. So go ahead and get my tick marks taken care of. And since I'm going to be moving between 2 and -2, because I have a general idea of what my base graph would look like, and I'm just going to start plotting points at those values. Now, some of you may very quickly become so accustomed to making the shifts that you'll be able to do all of this in your head. Hey, that's awesome. You're like, wait a minute, that's kind of tips upside down from what we normally do with cosine. Right. Cosine normally almost looks like a big kind of V shape, but that -a value actually flips my graph over. And if I wanted to keep going, it would start to curve back up and so on. But that's what I've got to start considering now. Take that base graph, periods and phase shifts, change this guy. My y value gets changed by that a value, and if I do have a vertical one. So they each have 2 that can possibly get changed with those. Issues on this first one, because we're going to keep messing with all these different strange looking. We'll switcherooski then. We'll hit up our next one. So we get our basic information down again. Now again, if this one is bothering you, being at the start, just move it to the end. I'm fine with that. So I look this time, I'm like, ooh, I do have a k value this time. So I'm going to be shifting up 1. That affects my y value. Just making a mental note to myself. I don't have an amplitude change this time. Okay, so that's really not going to change anything or do anything for me. So that's not a big deal. I'm good with that. So I get to this next one and I go, okay. So now my b value, I don't see anything in front of x, so my period's not going to change. That's always fine with me. So my vertical shift goes along with my k. I'm going to be going up 1, like we just mentioned here. My period didn't change at all. But I'm going to be shifting right pi over 4, which affects my angle measure. So it looks like I'm going to have 1 change with my angle measure, 1 change with my y. And if I'm feeling brave, can even try doing this, just kind of thinking about it. So let's see what we can do here, especially since our period didn't change. But you're like, ooh, maybe I want to look at this for a second, which is fine. If you want to look at it as, okay, I started with 0, pi over 2, pi, 3 pi over 2, 2 pi. But now I'm going to shift to the right, so I'm going to add pi over 4 to all of these. Now, I'd hope you're okay with the fractional part of this, and it's not really going to set you for much of a problem. Anything with 0, okay, that's going to be easy. Just look at these like they're just regular fractions. Pi over 2 is like 1/2. Pi over 4 is like 1/4. 1/4 plus 1/2 is 3/4. 1 plus 1/4 is 5/4. And you might even start noticing the pattern and not even have to really think about it anymore. 1, 3, 5, 7, 9. Otherwise, I could just do 3/2 plus 1/4, 2 plus 1/4. Work it out that way. And now I took care of that shift. So now I have oops, I needed to make one more line for myself. Now, would it have thrown you for a loop if I would have given you a graph and just had the pi over 2, pi? Hopefully you'd be able to figure out you could make tick marks in between to be able to make the adjustment. Just something to consider. So I didn't change with my amplitude values, but I do remember that I'm going to have to shift all of my values up 1 from where I normally would. So I start thinking sine. I'm like, okay, sine always starts at 0. So pi over 4 is my first one now since we shifted. So I'm at 0, then I have to go up 1. So I'm going to start here. This is in my same spot that pi over 2 normally would be, which is normally at 1. It shifts up 1. And then back down 1. This would normally be at -1, but I shifted up 1. And then these guys will just line up nicely. And I could keep that going either direction. But again, it's a comfort level right now, especially on phase shifts. If you wanted to make a little sketch to do this, I don't see an issue with it. As you do more, you'd get so comfortable that you'd be able to just make these naturally in your head. But especially if there's multiple ones, I'd kind of think about it that way. All right, let's knock these last two out and actually be ready to go with this section, finally. So let's see what we got. All right, graph at least one period of the following. All right, what info is important here? Let's see. No amplitude worries this time. Am I going to have a period change? Yes, because we have a b value this time. It's 2. So my period is now going to be pi. And I do have a phase shift because, again, anything in the parentheses, that's what it's going to be. We're going to be moving left pi over 2. Ooh, so we get to go into the negatives this time. You're like, okay. So I start thinking about this. And I go, okay. Again, if I were to give you a normal sine or cosine graph, which is what I'm going to do here, just so we can be ready to make adjustments if we had to. So you'd start looking at this and you go, okay, cosine normally starts at 0, 1. So normally we'd start right here, but I had to shift left pi over 2. So this point's going to shift left. Normally for cosine at pi over 2 I'm at 0. But again, I'm shifting left pi over 2. But here's something else I have to do. You're like, ooh, that's right. my period changed this time. So not only am I having to do this shift, but I also have a period change. Now, think about that for a second. So I have 0. Just to be thinking one more time here, so if you're referencing later, you can see. I need to think about the period change first. So when I'm doing all of these, dividing by 2, I'm cutting all of these in half. So before I start shifting, okay, so with my period change, I'm dividing all of these by 2. But then, and I'm going to make one more column for it this time, now I have to subtract pi over 2 on top of that. So that is where I get my first point that we already did. And again, we're like 1/4 minus 1/2 is negative 1/4. Half minus a half is 0. 3/4 minus a half is a 1/4. And 1 minus 1/2 is 1/2. So what I'm actually graphing, okay, are at these points with my regular cosine values. So these guys, using my 1, be like, ooh, negative pi over 4. 1/4, right in between 1/2 and 0, negative 1/2 and 0 in this case. So 1, 0, 0 gets me back to 1. Pi over 4, again, is in between those. Did I do something silly? 1, 0, negative 1, which would be down here. I'm a silly man sometimes. Went into sign mode here. 1, 0, negative 1, 0, 1. That's better. And I could keep going with that if I wanted to. So I shrunk, and I shifted. Fun, fun, fun in the sun. And like I said, if it takes for a while, because you saw even what happened to me there for a second, kind of seeing the shifts and kind of charting yourself step by step, we'll do what we got to do. Right. One more time. All right, let's see what we got working here. No amplitude change, so that'd just be 1. B value is pi, so divide by pi means my new period's going to be 2. Ooh, and I get multiple shifts this time. Vertical shift, up 3. Oops, I already got my period there. And my phase shift is right 1. Okay. So let's see. My period is 2, we're up 3, and right 1. And 1, 2. Be prepped with those. Okay. So let's see here. The only thing we're basically doing with our values is getting rid of pi. So I start thinking about those, and I'm like, okay, so I'm at 0 and a half, and 1, and 0. No, not in 0. Just draw the picture, man. So normally, here's where I am again. So we'll take one more peek at where we'd normally be and where we're going to end up. So now, when we divide by pi, 0, a half, 1, 3 halves, not 1.5, and 2. which is my completed period. So that makes sense. Here's where the fun starts, though. Now, I still need to shift this right 1. So I'm going to add 1. 1, 3 halves, 2, 5 halves, 3. So here is where I'm going to plot my values. So again, I go back to what I normally would do. I say, okay, wherever my first point is for sine is normally at 0. But I have an up 3 shift. So I put the first dot in. Normally at my second value, 3 halves, okay, I would go back down to what? Up to 1, and I'm up 3. So I'm up to 4. Because again, okay, this 0, oops, let's get that where I can see this here. So basically what we're doing is 1 we're at 0, then we're up 3, so it'd be up to 3. Here would be at 1, we go up 3, we'd be up to 4. When I get to 2, that'd normally be 0. I'm back down to 3. 5 halves would normally be at -1. But I have to go up 3. And finally at 3, I'd normally be at 0, but I had to shift up 3. It's just keeping all of my pieces in order, whether it's with a chart, whether it's doing a little scratch work somewhere, whatever it happens to be. Maybe it's drawing in the base graph and doing shifts. However you want to do it, that's what we're going to be attempting to do here. So, I'm actually going to put one more extra credit thing out there. On the back of this packet, kind of takes you back into yesteryear, remembering whether things are coterminal. Remember, that's whether they're positive or negative 360 degrees together. So like from 40 to 400, they're 360 degrees apart. They're coterminal. From 90 to 270, that's only 180 degrees. Good for reference, not good for coterminal. And I can kind of work through those, kind of get myself some review. If I get into 11 through 13, okay, they're giving me a point, giving me an opportunity to make a picture. So 3, 4 means I go right 3 and down 4. And what that allows me is to make myself a right triangle where I would need to find my hypotenuse, and then I could find all of my trig functions. Well, I see this is a perfect right triangle. Get a Pythagorean triple working. 3, 4, 5. And then again, calculate sine, cosine, and tangent based on those 3 sides, and my reference angle, again, always being the angle that's connected back to my origin. So I do that for those 3. And then the last 3 is kind of puts you into puzzle mode. And by that, let's see if I can just keep that all together. Okay, good. They're going to give you values to kind of let you know where things are at. For instance, you could draw a picture. Sine is 3 over 5, which is opposite over hypotenuse. And they're telling me the theta is in quadrant 1. Now, if I wanted to draw a quick sketch, I could do the 3, 5 thing, sort of like we did up here. Oops, except that's not where my 5 is. The 5 is the hypotenuse. Oh my Lord, Harty, today. I got a little too literal with that. I was given opposite and hypotenuse. That's what the sign was. I just made up my own thing, which that usually doesn't work well in mathematics. So I can draw these in based on what I know and come up with the other trig functions. if you want to do the back of the packet, so 27B, that would also be deemed extra credit for the next homework check, which again tentatively is scheduled for next Tuesday. So this one and the sheet that you got today are extra credit. Otherwise, finish off the packet, the more trig graphing practice. Oh, yes. Correct, yeah, the one you picked up today would be the first one.